Good morning, students. This is Latif sir. Today I'll discuss about the dual behavior of particles or matter. In the last video, I have discussed about the atomic model of Bohr, and I have discussed about the postulates of Bohr's atomic model and limitation of Niels Bohr atomic model. And today I'll give first the reason for the failure of Bohr's atomic model. Now, what are the reasons for the failure of Bohr's atomic model? First point, the wave character of electron is not considered in Bohr's model. Today I'll discuss about this point. What is the wave character of electron? But scientist Niels Bohr did not consider the wave character of electron. And second point, according to the Bohr's atomic model, an orbit is a clearly defined path. According to Bohr atomic model, an orbit is a clearly defined path, and this path can completely be defined only if both the position and velocity of electron are known exactly at the same time. According to Bohr's model, an orbit is a clearly defined path, and this path can completely be defined only if the position and the velocity of electron are known exactly at the same time. And this is not possible according to scientist Heisenberg uncertainty principle. And today I will also discuss about this point also, that is about Heisenberg uncertainty principle and wave character of electron. So these 2 points are reasons for the failure of Bohr's atomic model. Now, dual behavior of matter and de Broglie equation. What is dual? I have told in previous video, in the I think in the second video of this chapter, that radiation can show dual behavior, that is wave nature and particle nature. To explain photoelectric effect, black body radiation, you have to assume the particle nature of radiation. Now here, electron, protons, neutrons, these are particle, these are not wave, but the particle can also show wave nature. Who told? Scientist de Broglie. That's why I'm telling that the dual nature or dual behavior of matter. So scientist de Broglie in 1924 proposed that he proposed that the matter like radiation should also exhibit dual behavior. I have told that radiation can exhibit dual nature, that is wave nature and particle nature. Generally radiations are uh, wave, but they can also show particle nature. I have already discussed about this point. Huh. Similarly, matter, we know that matter are generally particle in nature, but matter can also show wave nature. That is, matter like radiation should also exhibit dual behavior, that is both particle like and wave like properties. And this means that like protons, electrons also have momentum as well as wavelength. As particle has dual nature, that is particle nature as well as wave nature, that's why particles can have a wavelength. Huh? So according to de Broglie, the wavelength of particle, huh, can be the wave equation can be written as lambda is equal to h by mv, or lambda is equal to h by p, where wavelength lambda is the wavelength of the particle, h is Planck constant, m is the mass of particle, and v is velocity of the particle. That is, according to de Broglie, if an electron or subatomic particles like electrons, very teeny microscopic particle, if moving, then this particle can have both the properties, that is particle nature and wave nature. That's why I am de Broglie, scientist de Broglie first gave the equation of calculating wavelength of a moving subatomic particle or microscopic particle, and the equation which is known as de Broglie equation, which is del lambda is equal to wavelength is equal to h by mv or h by p. Mv means mass of the particle, and v is the velocity of the particle, and mv means momentum. Mass into velocity means momentum. So you can also write lambda is equal to h by p. This is very important equation based on the dual nature of particle, and scientist de Broglie given this equation. The wavelength of matter have associated with a particle can also be calculated from the kinetic energy of the particle. The wavelength, that is lambda, is equal to h by mv or h by p. This wavelength of matter wave associated with a particle can also be calculated from the kinetic energy of the particle. If the kinetic energy of the particle is E, capital E, and we know that kinetic energy means E is equal to half mv square. Kinetic energy is equal to half mv square. So E is equal to half mv square, where m is the mass of particle, v is the speed or velocity of the particle. And now you have to do some rearrangement. Huh. So E is equal to half mv square. Now multiply both numerator and denominator by mass. That is, after multiplying the numerator and denominator with m, that is mass of the particle, the equation becomes E is equal to m square v square by 2m. Now mv means p, so m square v square means p square. M square v square means p square. So E is equal to p square by 2m. Now p square is equal to 2me. Just rearrange the equation. P square is equal to 2me. So p is equal to root over 2me. Now lambda is equal to h by p, h by mb or h by p. So lambda is equal to h by root over 2me. Okay, this is another form of de Broglie equation in terms of kinetic energy of the particles or of the matter. That is, lambda is equal to h by p or h by root over 2me. According to de Broglie, the electrons in a hydrogen atom is bound to move in the space around the nucleus due to the positive charge on the nucleus. Electrons are moving or revolving around the nucleus by the force of attraction by the due to the positively charged nucleus. So moving electrons in an hydrogen atom should behave as a standing wave. If the electrons move, electrons wave have told that the subatomic particles like electrons, that is microscopic substances or matter or particle, if they are moving, they can show wave nature. So when electron revolving around the nucleus, electron can also show some wave nature. And according to de Broglie, the electrons in a hydrogen atom is bound to move in the space around the nucleus due to the positive charge on the nucleus. So the moving electron in a hydrogen atom should behave as a standing wave. And if the standing wave like this, here wave nature of electron not considered as particle, here it is shown that electrons moving or revolving around the nucleus in as a wave, electron revolving around the nucleus as a wave. So here it is shown that wave nature of particle, that is wave nature of electron revolving around the nucleus in a particular cell. But the movement of electron are showing is showing by give is showing by considering the wave nature of electron. If the electron wave behavior in an atom resembles that of standing wave, each orbit must be equal to the whole number of times the wavelength, as shown in the following figure. In this figure, that is electron revolving around around the nucleus in a circular orbit, and the movement of electron is shown in the form of wave. And if you calculate the total number of full wavelength in this figure, you know that wavelength means distance between two similar points in a wave. That is, here you can say the wavelength is the distance between two tau or crest. You have already studied in class 10 physics. The wavelength means distance between two similar phase or distance between two tau or crest. Okay. In this figure, electron revolving in a circular orbit, and the wavelength of the total number of full wavelength in this figure, if you calculate, you will see that total 1 2 3 4 5 and 6, total 6 wavelength covers, covered the entire circular orbit, that is the circumference of this circular path. If the radius of this circular path is r, small r, then the circumference of this circular path is 2 pi r. And according to de Broglie, the circumference of this circular path, that is 2 pi r, will be equal to whole number of times of wavelength. That is, here if total circumference is 2 pi r, and here you can, if you count, you will see that total 6 wavelength, complete wavelength present. So 6, if the wavelength of this wave is lambda, then the total distance covered by 6 wavelength, that is 6 lambda. And according to de Broglie, this 6 lambda always will be equal to 2 pi r, that is circumference of this circular path. Thus, according to de Broglie, only orbits with length equal to whole number of times the electron's wavelength are possible. that is, according to de Broglie, the circumference 2 pi r, if the radius of this circular orbit is r, then the circumference of this circular path is 2 pi r, and according to de Broglie, this 2 pi r will be equal to the integral multiple or a multiple of wavelength of electron, that is n lambda. Okay, according to this figure, this circular path, if you count, then you will see that 2 pi r is equal to 6 lambda, because here total 6 lambda, 6 wavelength are given. Okay, but it may be changed, 6 or 5 or 4. Here according to this figure it is 6 lambda. Okay, so in general you can write 2 pi r is equal to n lambda, where n is a integer, n is equal to 1 2 3 4 like this, and lambda means, according to de Broglie, lambda is equal to h by mv. So by rearranging this equation, it becomes mvr is equal to n into h by 2 pi. I have told this equation, okay, when I am discussing about the Bohr's atomic model, that is mvr is equal to h by n into h by 2 pi. This is conditions for allowed orbit. Okay, now Heisenberg uncertainty principle. According to this principle, it is impossible to determine simultaneously the exact position and exact momentum or velocity of an electron. Heisenberg uncertainty principle, according to this principle, it is impossible to determine simultaneously the exact position and exact momentum or velocity of an electron or subatomic particles or microscopic particles like electrons. It is not possible to determine simultaneously both the position and momentum exactly. If you find out the position exactly, then there will be some uncertainty in the uh, determination of momentum or velocity of that particle. And mathematically, the Heisenberg uncertainty principle can be written as delta x into delta px is greater than equal to h by 4 pi. This is a mathematical expression of Heisenberg uncertainty principle. According to Heisenberg uncertainty principle, if you find out exactly the position or the momentum, you will not able to find out the other property, that is, if you exactly find out the position, then there will be some uncertainty in the finding out of momentum, or in the measurement of momentum, exact value of momentum. Okay, or if you exactly uh, find out found out the momentum, if you exactly found the momentum of microscopic particle like electron, microscopic moving particle like electrons, then there will be some uncertainty in the measurement or in the calculation of position. Okay, position and momentum of electron cannot be uh, exactly find out simultaneously. And mathematically, Heisenberg uncertainty principle looks like delta x into delta px is greater than equal to h by 4 pi, where delta x is equal to uncertainty in the measurement of position in the calculation. Delta x is the uncertainty in position, and delta px is the uncertainty in momentum. you can also write the momentum as momentum means mass into velocity. So delta x is into delta m vx is greater than equal to h by 4 pi, and mass of a particle is always remains same. That's why mass is constant. So you can also write this equation by rearranging again delta x into delta vx is greater than equal to h by 4 pi m. Delta x into delta vx is greater than equal to h by 4 pi m, where delta x is the uncertainty in position, delta px is the uncertainty in momentum along with the x axis, and delta vx is the uncertainty in velocity. Now, significance of uncertainty principle. It rules out the existence of definite paths, or it rules out the existence of definite paths of electron and other similar particles. And next point, next significance of uncertainty principle is the the effect of Heisenberg uncertainty principle is significant only for microscopic object, that is very light particles. Huh. And and is negligible for macroscopic object. So the effect of Heisenberg's uncertainty principle is significant only for microscopic object and negligible for macroscopic object. Okay, and these two Heisenberg principle and de Broglie equation both are very important, and there will be some small numerical you have to do using Heisenberg equation, mathematical equation of Heisenberg principle, Heisenberg uncertainty principle, and using de Broglie wave equation. Okay, thank you.